Good morning, good afternoon, good evening. Whatever the case may be, we are back and better than ever. And we, boys and girls, are now solving systems of equations, linear equations in this case, by graphing. And here's a picture of two equations that are graphed. And we were able to solve them by finding the point of intersection, because that is actually where they are equal. And the good news is we are going to use our graphing calculators to do this. But if we're going to use our graphing calculators, we need to get these systems in a form that we can graph them. So I am going to subtract x from both sides to solve for y. We always need to solve our equations for y. X minus x is 0, so this goes away, kaboom, and I'm left with y. So y equals, I cannot combine 4 and negative x, so this would be negative x plus 4. Okay, and then I have this one, 2x minus y equals negative 1, so I'm going to solve this for y. So I'm going to subtract 2x from both sides, minus 2x here, okay? And this goes away, 2x minus 2x is 0, so I'm left with negative y equals, I can't combine these because this has an x and this is just a constant, so negative 2x minus 1, and I need to solve for y, not negative y. So I'm going to fix that by just multiplying through by negative 1, or you could divide each term by negative 1 if you wanted to. So negative 1 times negative y is positive y. Negative 1 times negative 2, don't forget your equal sign, is positive 2x. And then negative 1 times negative 1 is positive 1. So my new system, I have this guy. It's the same. It's not a new system. I just have rewritten it so I can graph it. I have y equals negative x plus 4. And then I move this guy down and I have y equals 2x plus 1. You don't have to move them down if you don't want to. I just wanted to show you that we have a system. And so we're trying to find out what value of x and y, what coordinate, what x coordinate, and what y coordinate can we get that solves, that is true for this equation and for this equation. And all we have to do is graph it. And first I'll show you on the Inspire. So you just punch that in, negative x plus 4, and you graph it. Kapow. And then to get another graph, you hit tab, and it comes up for you right there. And you put in the other equation, which was y equals 2x plus 1, and you hit enter. And you can see they enter very nicely, they intersect right there. So to find the intersection, watch my steps, menu, analyze graph, and I want to find the intersection. Okay, and it's the lower bound here. You see where it says lower bound? That just means you want to get to the left of the intersection point, and you can do that using your arrows. Here, watch. See, it'll move it left, move it right, or you can use your mouse pad, which is what I'm using. It's easier on the computer. And you just have to click to the left of the lower bound, and then you can arrow right. It takes a while, or you can just use this little mouse pad to click and, oops, I totally messed that up, to click and drag, there we go, until the point pops up, and the answer is 1, 3. On Desmos, oops, saw my secret there, same thing, I'm going to put in negative x plus 4, it's a little easier on Desmos, and I hit enter, and then 2x plus 1, enter. And then you just have to move your mouse and just get real close to the intersection point. You see how it's right there, and you click, and it'll find it for you. And there's 1, 3. You just click right on the intersection. So what we're claiming is that our x and our y are 1, 3. And we're hoping that this is our answer right here. Okay, so how do we test it? Well, we can put it in both equations. So I'm going to replace y with 3. Does 3 equal negative x? So negative, and then I replace the x with the 1. Negative 1 plus 4. Does it? It sure does. Negative 1 plus 4 is 3, so that's a check. And if you want to do a double check, then you just replace 3 with y again. 3 equals 2 times 1 for x. Does 3 equal 2 times 1 plus 1? 2 times 1 is 2 plus 1 is 3. Yes, so we know we're right. And I also want you to sketch, and I mean just sketch. It does not have to be perfect. Okay, I just happen to have a nice little graph there. Just sketch the graphs that you use. So I'm going to go, I guess I'll go here. So you look at the intersection points here at 4 and at 4. So that's good enough. I can just do a quick little sketch. Let's see, 4 and 1, 2, 3, 4. And I'm not even going to get my straight line thing. I'm just going to kind of do this. Okay. So that is negative x plus 4. And then I'm going to sketch this one, 2x plus 1. So I'll take a look. 2x plus 1, it goes through 1 and then goes through the point 1, 3. That's good enough for me to sketch it. So 1, 1, 3, just need a couple of points. And I go through there. And I just label it y equals 2x plus 1. And then label the point of intersection 1, 3, and I am happy. And you are done with that. Okay. All right. So next, we have to do this. See if there's a solution. Okay. So I'm gonna change. Let's see. X plus y equals 3. Subtract x from both sides, and that becomes y equals negative x plus 3, because you can't combine these. Okay, and then we have, let's see, 2x plus 2y equals negative 4. I'm going to subtract 2x. Okay, so then I have 2y equals negative 2x minus 4. And I'm going to divide everything by 2, by 2, by 2, everything. And I'm left with kapow there. Y equals negative 2 divided by 2 is a negative 1. Negative x. Negative 4 divided by 2 is a negative 2. Okay, so I'm going to graph these. I'm just going to graph them on one calculator. I'll do Desmos, and then next time I'll do the Inspire. So let's see. I'm going to go here. I need a new blank graph. There we go. So my two equations were negative x plus 3, bam, and then negative x minus 2, bam, okay? And if you look, these lines are parallel. They are never, ever, ever going to intersect. So we would just say that there is no solutions. You can also tell because they have the same slope. When you solve for y, they have the same slope there, the new, which means they are parallel. Okay. So we'll go back and we will say that there is no solution, comma, lines parallel. Something like that. Okay. And then just a quick sketch. Boom, let me get my stamp. All right. And let's see. So I think we had, what? We have a y plus 3. So maybe here and here. So we had something like this for y equals x minus 3. You can look back at your calculator. I just don't want to waste the time. And then negative x minus 2, something like that. It doesn't have to be perfect. Y equals negative x minus 2. Okay. Last example is to determine this solution. Looky, looky, looky here for this system. So that's already solved for y. So this one I'm going to solve divided by 2, divided by 2, divided by 2. Kapow, y equals 6 over 2 is 3. Negative 4 divided by 2 is negative 2x. So I have my two equations, and hopefully you're noticing something here. We shouldn't even have to graph it, but let's go ahead. I'll use the Inspire. And if you don't want to mess with this same graph, here's all you do. You can get a brand new graph. You want a new page. Right here it says plus page. So I'm going to do Control here, and I'm going to add a graph. And then what did we have? Negative 2x plus 3. Kapow. And then I hit Tab, click, to put in the next one, and I'll put it in that form, 3 minus 2x, boom. Oh, look at that. It graphed right on top of it, didn't it? Wow, the lines are on top of each other, so what we say when that happens is there are an infinite number of solutions, infinite solutions, infinite solutions. And that's because it's the same line. It's the same line. All right, so, and then a quick sketch of that. And let's see, so that would be something like this. You only have to graph one line. I hope you understand that. So it's going to be something like that. And I would just do that. Oh, that's a horrible sketch, but it's kind of hard to sketch with this pen thing. I'm going to erase it. I can't take it. I can't take it. That's not much better. Okay, so that's y equals negative 2x plus 3. And what I was saying before, that you should notice something, this is just written a little differently. Can't I rewrite this as y equals, put the negative 2x first, then the plus 3? And you can see it's exactly the same. And so you know it should be an infinite number of solutions. So that is it for this lesson. Let's check in on our friends here and see how they're doing before we sign out. Hope you enjoyed it, and we will see you next time because I am out. Woo!